number sequences with the graphics calculator. We often want to graph a number sequence, and there's a few reasons for that, and the most simple way to do it is with a graphics calculator. So I've got two number sequences here. I'm actually going to start with this second one, sorry about that. You'll remember I said once before that if you put n and tn at the front of your number sequence and put in the n values, then it looks awfully like a table of values, where n is the x and tn is the y. And in fact, any number pattern that comes from a rule pretty much is a table of values for a graph. So the way that you graph a number sequence, or one of the ways when you've got the first few numbers, is you put them into L1 and L2. Sorry, I left some number sequences in there. And n, the position, is what the term depends on. The value of the term depends on the position that we're at. So n is our x, our explanatory variable. And the term, the value of it, depends on what position it's at. So our y is tn. And as long as I've left scatter plots on, which I have, then Zoom 9 will graph my number pattern. You'll notice this is an arithmetic number pattern. It goes up by 5s. And an arithmetic number pattern makes a straight line. It's just going up by 5 each time. So if I went back here to term number 0, I'd go back 5, I'd get 3. So I'd get a y-intercept, and going up by 5 each time means my gradient is 5. So I can explain this as a linear positive relationship. This one here, put in n and tn, go back to your graphics calculator, stat edit, make sure we've got all our data in, and I've got, now it's pretty obvious that this, is not arithmetic. And it's pretty obvious that it's not linear. This is a non-linear, but still positive, as n goes up, tn goes up, relationship. So we can describe each of these. Positive, non-linear relationship. Sorry about running out of space. This one was a positive linear relationship. So when you're graphing it with a graphics calculator, use n as x and tn as y. This is a type of relationship or pattern we'll learn about called a geometric sequence. Oh no, this is, sorry, geometric. This one's arithmetic, we know that one. And we'll learn about geometric sequences a bit later. Now, graphing from a rule is also possible. You can enter a rule in recursive form into a graphics calculator. I'm not very fond of doing it. I'm going to have to refer to my notes. I'll give you a page of notes. It will look like this, but I'll go through how to do it. So I want to enter the fact that my first term is 9 and I've got a rule, Tn plus 1 is Tn minus 2. I might want the terms in the pattern, or I might want to see the graph. So we're going to change our mode, and this fifth set here, function, parametric, polar, or sequences, SEQ for sequences, we're going to change that from function over to sequences. Now what that does is when we push y equals, I don't get a spot to enter just straight line equations and stuff anymore. I get a spot to enter number patterns. Now, we've got to be a bit careful about what goes in there. N min is going to have to be 1 because that says n, the pattern of the term that we're at, starts at 1. So n starts at 1, the first pattern of the term. That makes sense. The un is where our term rule goes. Rule goes here. And to understand this, you'll have to remember when I first introduced you to these terms, these rules, I said the other way we could write this was Tn equals Tn minus 1 minus 2. Both of these just say to get the term, you want the term before it take away 2. But it's sort of dependent on whether we did Tn plus 1 from Tn or Tn from Tn minus 1, but they're both saying the same thing. This one is using this, so un is basically Tn, except u is t now. It's annoying, I know. So I want to have the previous term, which is going to be un minus 1, and then I want to take away 2. To get that, to get u, I need the u that's above the 7 here, so that'll be second function 7. In brackets, I'm going to want n minus 1, and I get n from this button here, where it's got the options of x, t, theta, and n, and when I push this just once, it'll give me n minus 1. Just type that with minus 1. Close the brackets. So I've got in Tn minus 1, which is of course un minus 1. Now I just need to do take away 2. And I've got the rule in. Then the last one we need in is our starting point. And that's un min. Now remember, n min is the smallest n, which is 1. U is t. I know it's confusing. So this is t1, which is the first term. And so that, I just have to put the first term in, and the first term here is 9. So here, I want 9. And then I have set up the rule for my pattern. Hop out of that and go to second table. You'll get an error when n is smaller than 0, but where n is 1, sorry it's a bit blurry here, I don't think I can focus anymore. I've got Tn is 9. 7, 5, 3, this is starting at 9 and taking away 2. And if I do zoom 9, I don't get to graph it because I left my scatter plots on. So you'd have to turn your scatter plot off, then do zoom 9, and there is my graph, gradually declining down. So it is a little bit tricky. this is where, so my steps are mode, you go from function to sequences. In your y equals, you put all this. I'll give you a page that describes this. To see the number pattern, second table, and zoom 9 with stat plots off for the graph. Sorry, writing going very messy here. It's late on a Saturday afternoon. I'm going home. Bye.